It's very important to be passionate about your science. You're not going to make a lot of money as a scientist, so if you're in it for the money, you're in the wrong field. It's what allows you to get up in the morning and have fun coming to work.
Making people feel better is probably my greatest passion, and I'm a very lucky person because I can do research in the same field that I actually work as a clinician. So I see the result.
There's nothing more rewarding, I think, in life than coming up with a question and finding out the answers yourself. I do the science of decision making. So we explore decision making through different contexts. We look at decision making in visual search. We look at decision making when people have to make fast versus slow decisions.
So if you could respond to X's and withhold any responding to the O's.
We use sleep deprivation as a context to explore decision making. This has been a fairly important topic because we live in a sleep-deprived world. These are the kind of things that can have long-term consequences that we're not currently fully aware of. We're using functional magnetic resonance imaging, fMRI, which is a neuroimaging technique to explore which parts of the brain have more activity when people are making certain kinds of decisions. We're looking at decision making in a broader context, so we're interested in understanding how it is that we can apply these general principles to something more specific.
There's a lot we don't know about contaminants right now. There are tens of thousands of contaminants in Canada that we're just starting to get an idea about. We don't really know how they're distributed. We don't know whether they degrade quickly or whether they stick around for a long time. As the climate is changing, contaminants are going to change as well.
How's your sample going today?
Good. This is the third run of the unfiltered Big Dam West lake water sample.
Our lab is based around contaminants. Particularly, I look at mercury and how does mercury move in ecosystems? How does it get into the food chain and cause trouble with organisms and humans who might be eating those organisms? We know that it's being released from fossil fuels whenever we burn them, and it's traveling all around the world for about 2 years, and it gets deposited in remote ecosystems like Kejimkujik Park, and then it can accumulate. And why it accumulates and why certain areas end up with a lot of mercury in the food chain is one of the questions we're trying to answer. We look at trace levels in here. We look in parts per quadrillion levels. So that's akin to filling a football stadium with sand and being able to identify 5 or 6 grains of black sand in that football stadium.
As soon as I was faced into my first situation of pediatric palliative care in my training, I knew this is what I wanted to do. I'm known as a symptom expert. Any kind of symptom, pain, breathlessness, fatigue, nausea, how you can assess them, and so obviously how you can treat them.
What's his way of telling you that, Mommy, I'm in pain?
One of the major challenges we have is children who are young or children who are cognitively impaired. They cannot tell for themselves what they're living through. So we use a lot of cues from either the parents, who are usually the expert around their child, but also observation. Cues could be they make a funny face, or could be how they are breathing. And so we're trying to build observation scale that we can use that would be fairly objective even when you don't know the child. It's nice to publish paper and it's nice to have an ICB, but there's nothing that will replace a kid smiling for me. So it's the best job in the world, I think. I'm very lucky.